All right, so this video is for geometry, section 8.4, and it's going to be finishing up the trig function lesson that we started in class. So we've talked about SOHCAHTOA, we've talked about the trig functions, the sides that they relate, and now we're going to go ahead and go through some of the examples and actually solving for missing values. So if you're in your note packet, we're going to continue on with the note packet, and we're just going to pick up with the examples that we left off. So let's go ahead and start there. So the first example looks like this, right? And don't forget, we have this mnemonic device of SOHCAHTOA to help us remember what trig functions we're using, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we look at this first example, from the angle that we're using, the opposite side is x, the hypotenuse is 15. Well, what trig function uses opposite over hypotenuse? Well, opposite over hypotenuse is sine. So sine of our angle is equal to opposite over hypotenuse. Then to solve for x, we say, well, what's the opposite of dividing by 15? That would be multiplying by 15. So I have to multiply both sides by 15. That isolates our x, gets it by itself, and we have x is equal to 15 sine of 70 degrees. So in order to solve that, right, if you don't have a calculator at home, we can get around that by using our good friend Desmos.com. So Desmos not only has a graphing calculator, but it also has a scientific calculator. So if we look at our Desmos scientific calculator, just desmos.com/scientific, I can type in 15, so 15 sine, which there's a sine button over here, and I'm taking 15 sine of 70. So that should get us 14.09, which if I round, most of these are going to round to the nearest 10. So I'm going to put 15 or 14.1. 14.1 is 15 sine 70. And just make sure that you're in degree mode here, right? All of these will be in degrees, so just keep it in degree mode. So that will be the first one. So now if we go back to the notes, the next example looks like this one. So we have a 48-degree angle, we have an opposite side, and we have an adjacent side. So you come up to your SOHCAHTOA and say, which one is opposite over adjacent? Well, that is tangent. So tangent of our angle is equal to the opposite over the adjacent. Well, how do I get rid of this x that's being divided? I multiply it over. So I have x tangent 48 is equal to 85, but x is not isolated in this one. So I have to get rid of this tangent 48 that's being multiplied. The opposite of multiplication is division. So x is going to be 85 divided by tangent 48. So once again, I'll go back to my Desmos, my calculator. If you have your phone, you could easily use your phone calculator as well. But for those of you that don't, we can use Desmos. So we're going to type in 85. So 85 divided by tangent of 48 and make sure once again we're in degrees, and that should give us approximately 76.5, again if I round to the nearest tenths position. Right, so that calculator is pretty nice, especially for these trig functions. You can either click on the numbers in the trig functions or you can just type them in. It's a pretty user-friendly calculator. All right, so then we go to our third example. Our third example is down here. We have an angle of 28 degrees. We have the opposite and the adjacent, right? Except for now, the opposite is the unknown instead of the adjacent. So if I take tangent of my angle, it should equal the opposite over the adjacent. To get rid of that 22, I'll multiply it over. And this one's nice because now if I multiply it over, my x is isolated. X is just 22 tangent of 28. All right, so let's see what 22 tangent of 28 is. And we'll put it once again into Desmos. So if I do 22, I click on my tangent, 28 degrees, I should get 11.697, which if we round to the nearest tenth, I'm just going to make it 11.7. All right, and then we have one more example. We have, let's see. Oh, I didn't mark my example down here. Give me 1 second. So if we look at our last example, we have an angle of 64 degrees, and we're trying to find the hypotenuse. So let's see if we can do that. Let me switch over here. So we'll go back to our notes. And the last example you have should look like this. So from the 64, we have the adjacent, and we have the hypotenuse. Well, adjacent over hypotenuse is cosine. So cosine of my 64-degree angle is equal to adjacent over hypotenuse. So to get x by itself, I'll multiply it over. So I'll get x times cosine 64 equals 48. And then to get x isolated, I divide. So x is going to be 48 divided by cosine 64. So that's one last time here. Let's go over to the calculator and share that with you. So go back to Desmos, and if we type in to Desmos, 48 divided by, and we're doing cosine this time, cosine of 64, that should give us 109.5 if we round to the nearest tenth, 109.5. So that's going to be it for this video. You have 12 examples below it. They're practice problems in your notes. Why don't you go ahead and work those out? And the answers to those will be posted on Classroom at some point. So good luck. And if you have any questions, feel free to comment on the video. And please like and share. It helps out the channel. So we appreciate, and we'll see you soon.